This short video will describe the CIMSS Tropic website, what's on it, and how to find it. I'm Scott Lindstrom from CIMSS. The Tropical website is shown at the URL listed on the slide here. This is the front page when you go to the website. The map includes currently active storms or invests. The I is for region of investigation. There are many links on this front page, especially the 8 links under the map. These go to specific websites for products that may be useful before a storm forms or while it is active. The 8 links are shown here. Advanced Dvorak Technique, which is a satellite-based intensity estimate. The Advanced Microwave Sounder Unit imagery page. Archer, which is the Automated Rotational Center Hurricane Eye Retrieval. This is for center fixing the eye, and it's also useful for eye wall replacement cycles. Mimic TC. Mimic is Morphed Integrated Microwave Imagery at CIMSS. Mimic TC shows you information about the hurricane. Mimic TPW shows total precipitable water. SAL is the Saharan Air Layer Analyses. These are done in the Atlantic Basin only. SATCON are satellite estimates of wind speed and mean sea level pressure. And new in 2020 is a TC diurnal cycle, which gives observations of nighttime changes. If you click on ADT, you go to a page that lists storms, and if you click on a storm, that will give you the latest listing for that particular storm. This is for TD6E in the Eastern Pacific. You can go back and view earlier estimates in the archive as well. This gives information on the satellite estimates of intensity. As a storm intensifies, you get more information in the ADT page. This is the page for Hurricane Douglas as it approached Hawaii in 2020. And you see it's a fairly long listing. There are history files you can click on. There is passive microwave information. There's satellite imagery, time series of wind speed and estimated mean sea level pressure at the center. And you still have the ADT information at the top of that page. Microwave energy can penetrate clouds. The AMSU, the Advanced Microwave Sounder Unit, gives satellite estimates of what's going on inside the cloud. If you click on AMSU on the CIMSS Tropical page, and you can choose a storm to view from the drop-down menus. Once you click on a storm, you will see different AMSU channels presented for that storm. Mimic TC gives you this kind of information where one microwave pass is morphed into another. The example shown here is Douglas from 2020 as it passed to the north of the island chain of Hawaii. Some useful information is shown: the maximum wind speed and how far away the observation is from an overpass. Distance away from the overpass is changing with time. SATCON gives plots of pressure and wind speed as estimated from satellite. This example is from Cyclone Vicky back in February of 2020. You can see estimates of the maximum sustained winds and of the mean sea level pressure. The top part of the CIMSS page shows active storms. If you scroll down, you see basins, and you can explore information in basins to determine if conditions favorable to tropical cyclones are present. Mouse over the location and click on Winds and Analyses, and you get information that looks like this. Notice all the different things you can look at: upper level winds, lower level winds, wind shear, other things as well. The upper level winds, you have 3 different colors: 100 to 250 millibar, 251 to 350 millibar, and 351 to 500 millibars. You can move backward in time, you can zoom, and you can also switch to different basins. Lower level winds can also be viewed. So here we have 400 to 599 millibars, 600 to 799 millibars, and 800 to 950 millibars. Wind shear can also be viewed. This is a screen capture from the middle of winter in the southern hemisphere, so the wind shear is pretty unfavorable to tropical cyclogenesis over most of the domain. That's what those red contours mean. There are regions nearer to the equator in the northwest where the wind shear is fairly small. The wind shear is a difference between the average of the upper winds, 150, 200, 250, and 300, and the low winds, 700, 775, 850, and 925. You can learn that by clicking on Product Info. This Product Info tab is available for each of the product tabs that you can look at. How is shear changing with time? That's also important to look at. Solid lines show that it's increasing with time or becoming less favorable for tropical cyclogenesis. Dashed lines show you where it's decreasing with time. There are also other wind level analyses, upper level divergence, low level convergence, and 850 millibar vorticity. The latter is pretty handy for tracking tropical impulses, and also visible cloud drift winds, which I'm not showing. So we just looked at wind and analyses. You can also look at images and movies. If you click on images and movies, you see a variety of satellite imagery, water vapor, infrared, that's the window infrared, with different enhancements. Click on the product info link for information about the enhancements, and you can also look at animations. You can also look at global mosaics. These look something like this, where we have water vapor and infrared, and we also have movies available. Layer mean wind analysis gives you information about if there is a storm, what direction will it be moving. We have different layer winds here, from 700 to 850, for example, 500 to 850. You'll notice in the button, what kind of storm will this mean layer wind steer? For example, if you have a very weak storm, greater than 1,000 millibars, less than 45 knots, 700 to 850 might be the valid steering levels. If you have a very strong storm, so the mean sea level pressure is less than 940 millibars and the maximum wind exceeds 120 knots, maybe you should look at the 200 to 700 millibar winds as a steering level. When a storm is present, if you click on the icon, you are taken to a separate page where there are storm-centered analyses, including forecast tracks. So in this case, if you were to mouse over what was then Tropical Storm Douglas in the Eastern Pacific, a box pops up, tells you what you're looking at, and then if you click on it, you come to a page that looks like this. What you see on top is what is shown and also what is overlain. So you notice under satellite imagery, nothing is clicked, but there is something that's overlain on top of that nothing, which is the track and the forecast of the storm. That's the default. Then you can choose what you want to look at. For example, you can look at sea surface temperatures. Where is the storm moving, and how is the sea surface temperature changing along the forecast path? What's the moisture look like? This is looking at mimic total precipitable water. The date and the time of the base image is shown. You can also look at AMSU channels. So here I have channels 5, 6, 7, and 8. Channel 5 being lower in the atmosphere, channel 8 being pretty high in the atmosphere. You can look at 85 gigahertz microwave imagery. 85 gigahertz shows features in the upper part of the tropical system. Again, the date and the time of the image and the satellite are shown. You can also view MPI MSLP, that is maximum potential intensity, which is a function of the sea surface temperature and of atmospheric profiles. So you can see how strong could the storm be on the path that it's moving. You have MSLP and you also have peak winds. And if you toggle between the two of these, you see there's nice spatial correlation between the two of them. You can look at wind shear, color-coded for goodness. The overlay includes the shear level and the day and the time. So we're looking at the 200 to 850 millibar wind shear. Green are fairly small values, yellow are a bit higher, and red values are unfavorable. The deep layer mean wind is also shown. The overlay includes the layer levels and the date and the time. So this is 500 to 850 millibar deep level mean wind. This might be the steering level for this particular storm at this time. ASCAT wind can be shown as well. ASCAT winds are on MEDOP. You can also look at winds at different levels. They're color-coded as shown in the key. You can look at low-level convergence. You can look at upper-level divergence. If you're interested in shear, if the storm is not present, you want to go to the domain of interest, and then you can find the shear that way. If the storm is present, click on the storm and you'll find a storm-centered analysis of shear. And if you need to know information about this product, You can click on the product info if you're looking at a domain, or you'll find the information in the printout to the right of the image if you're looking at a storm. I hope this was useful. Here's my email if you have questions. That's all I have. Thanks for listening.